Today's topic is data structure, classification of it. Okay. So before understanding the classification, let us try to understand the importance of data in the computer. So to understand the data in a computer, so what I did is I selected the block diagram of computer from your textbook only. So this is one. You see, input and outputs are necessary. Okay. Other than that, see, there are two major parts. One is central processing unit and the other one is storage unit. So this is the unit where we store the data. Without data, there is no computer. Okay. If you take a human being, without memory, there is no human being. Without memory, human being cannot behave properly. So data is so important in the computer. And here we will try to understand the different types of data and how it is classified. We will study this topic in terms of question and answers. That is a very quick route for the preparation of the exam. So first question is, what is the data structure? This is a very fundamental question. Answer is, a data structure is a specialized format for organizing and storing data. So data structure is a specified means some rules and regulations are given. Format, it has got its own format and it has got some rules for organizing and storing. Organizing means how you arrange and how you store it. So this definition you should reproduce as it is in the exam. A data structure is a specialized format for organizing and storing data. In the examination, for all these words, specialized, format, organizing, storing data, it will carry some marks. So you should not write in your own sentence. These things, as far as possible, you should write as it is. Okay. Then second question, what is data representation? What is its representation? Computer memory is used to store the data which is required for processing. Computer without data, it cannot do any processing. This process is known as data representation. Again, I will read. Computer memory is used to store the data which is required for processing. First it has to store the data, then only it can process it. This process is known as data representation. Okay? Very straightforward. Almost similar lines you should explain. Okay? Then third question. What are the classification of data structures? Now we have come to the real subject. What are the classification of data structures? Broadly, data is classified into 4 types of structures. Okay? It is a very complex way of classifying. Anyway, I will show you the diagram given in the book. Then I will write the type. So this is the classification of data structure, block diagram. See, data structure fundamentally or basically it is divided into 2 types. Primitive data structure, non-primitive data structure. Okay. So this what it is we will understand. Then it has got so many sub classifications in this. These things when you go into the deeper subject we will understand. Non-primitive data structures, again it has got its own division. Okay. All these things we will see later. So I am interested only in these 2. The lists can be linear data structures, non-linear data structures. So here we will write the definitions of primitive data structure, non-primitive data structure, linear data structure and non-linear data structure with some examples. Wherever it is possible, we will try to give examples. Okay. So now we will write, we have seen the block diagram. Now we will write the four types. Primitive data structure, primitive data structure. Second one is non-primitive data structure. Third one is linear data structure, and fourth one is non-linear data structure. So primitive means very basic. That's what primitive, non-primitive is the basic classification, and this is very specific. Linear, non-linear. This you will try to understand when you go into the detailed definition. So when you ask this kind of question, just you have to give this depending upon the marks. Okay, then we will go to the next question. Describe data structures and give some examples. Okay, I didn't tell explain with examples, just give some examples. So primitive data structure. So this is primitive. Okay, as a mistake. Primitive data structure. See, data structures that are directly operated upon by mission are known as primitive data structures. Okay. So there is one more definition actually. You can write this also. Data structures that are directly operated upon by a mission level instructions are known as primitive data structures. This is also okay. What I have written is very very simple language. So data structures that are directly operated by a mission level instructions. You know what is mission level instructions? If you know assembly language, it will come. These are the in the software, the last level where computer CPU can understand directly from mission level instructions what to do. Compare, add, subtract, and all those things. So that is primitive. So these instructions primitive data structures that are directly operated upon by a mission level instructions. Directly using mission level instructions, you can call or store that kind of things. Okay. So examples are integers. Directly you can define. Machine can understand straight away. Logic data, 1 or 2 or high or low or true or false, that also can be told directly to the computer. Character data, if you are typing some text, then you can directly give A, B in ASCII code, it will understand. So that is this. You can write this or the other one which I showed from the textbook for the primitive data structure. Second one, non-primitive data structures. These are complex data structures. They are complex in nature. Means it is not very simple like this. They are further classified as arrays, lists, and files. Okay. These are further classified. I showed in the book arrays, lists, and files. Okay. That is just we can see. Here you see arrays, lists, and files. Okay. So for this I have not given any examples. So third one is linear data structures. This is actually further explanation of non-primitive data structures only. In these structures, the data items are homogeneous elements and are referred by an index. So you know index, it is some kind of identifying it. Homogeneous means it is same. Okay, homogeneous material means it is actually, if you take some bar and if you cut at different places, it should be same. So in here also, it is, suppose if it is text and um, numbers, then everywhere it will be text and numbers. And if you say numbers, only numbers will be there. And it is indexed and then put in some places. So in these structures, the data items are homogeneous elements and are referred by an index. So this is what is called homogeneous. Okay. So example, stacks or queues. So these are the examples. This you should remember. Then nonlinear data structures. This is the last one. In these structures, the data item is connected to several other data structures in a way that is specific for the reflecting relation. So these data you cannot store at one place, in one place, because it is maybe big or it is connected to many other things. So that is explained here. In these structures, the data item is connected to several other data structures. It may be connected to several other data structures in a way that in a specific for the reflecting relations. It will show its relations with the other things. They are arranged in sequential structure. These things you will understand if you go further into the subject. Sequential means one after the other, it is arranged. So examples in this case is trees and graphs. For example, trees means the Google, the data how it arranges is in this trees format. So that if you ask some question, it can go anywhere and then it can identify it. Okay. So that way it is arranged. So these are very important. All these modern softwares, they use trees and graphs where the data is very huge, and if you want to randomly access, then trees are important. So this is the first class. Hope this style of teaching is okay. So you you go through this. So we will meet in the next class. Okay.